Okay, let's move to the second part. Okay, after cleaning the data set, I had to save it to another folder, which is the clean data folder, which I saved the data set, which will be used for further analysis. Okay, let me close this one. Okay, these are the metrics and the threshold, but it also consisted of their analysis, but it was a playground, so there were most of the rough work I did here. But eventually, let me just go direct into the where I calculated the standard metrics. Okay, in possession, load the data set as usual. Okay, I had I had to find I had to match the image ID from the manually generated defects and the system generated defects. I had to match the image ID so that you find if the system predicted actually favored the system. I had to match the defects. So, okay, after matching, I came out after matching the defects. I came out with one data set that although they matched on the image ID. So you see, the resultant data set was like more than 600,000 rows. But okay, I'll tell you what next. But you see here, this XY manual and XY predicted were not very aligned. So I had to align them to be read by the Shapley polygon. That's why you see this function. I had to pair them, and now they are paired like this. You see, I had to pair it in form of XY, 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 so that they can be read by polygon. Okay, now because of the first, okay, yes, allow me to break. After finding using a resultant data set and matching by the image ID, it resulted to more than 600 rows. Okay, each row representing a defect matched between the manually generated and the system generated defect. So I had to use the IOU to find which polygons overlap. So I created this function called the polygon IOU. To this will detect the polygon that intersect from the XY manual and the XY predicted. So as you can see here, no, now they were another polygon. After creating the polygon, there were polygons that had intersecting. They had intersecting parts, so I had to buffer it to match the intersecting part to remove this extra part so that we can calculate the area and find the margin because this is not a polygon. This is a clear polygon. See, so this was just some cleaning that I had to do. After cleaning, I had to count. There are also annotations that were like straight lines that I had to remove. Okay, next I detected them, then I removed them. You see, there are like 25 detections that just detected as a straight line, not polygon, no polygon was drawn. You see.